Hello everyone. Hello everyone. Today we're going to be going over an introduction to functions, recursion. These are really essential topics to your competitive programming journey. And we'll also go over some fundamental data structures such as vectors, maps, and sets.
Yeah.
So taking a look
So
at our table of contents here. So we'll start off going over, like I said, the data structures that you guys will have to know for competitive programming. These are kind of the basic data structures that you'll be using like almost every problem. Vectors, map sets. So we'll go over that. We'll move on to an introduction to functions, how they're used, and like different types of functions. Then we'll go over recursion, what is recursion, how to use it, its connection with functions, and then finally we'll go over homework review. We put homework review at the end this time because we wanted to be able to kind of implement some of today's concepts to show how it can be done easier and how basically what we're showing today is like an advancement of before.
okay, now I'll go over these data structures. So a really important data structure is a vector, and I use it myself a lot. And why it's so effective is because they have the ability to resize themselves, they're dynamic, and regular arrays are static, so their size can't be changed, but that's not the case with these vectors. And beyond that, vectors also have access to a lot of very useful functions that allow you to get certain elements in constant time, or you can like remove elements very quickly or get the size. So let me just go over some of these functions on the right. So at the beginning, vector int apples, parentheses 3. So the parentheses means you're making the size, declaring the size. You don't need to do that, but in this example, I'm just going to declare the size right at the gate. So we have an empty vector size 3 storing zeros by default. And then I'm going to assign the first element a value 5 using the assignment operator and accessing apples of 0, just like I would for a normal array. And then I want to resize it. So I'm going to call the resize function, and it's going to expand the size of that. And then now I'm going to push back 6. So now we have a vector of size 6. You can't do this with a normal array. You'd have to like create a whole new array and then like change the last element. So basically like this is where vectors come in handy. You can change the size, and then now instead of doing like length equals size of r divided by size of first element like I would have to do for arrays, I can just simply print out size and it gives me 6. So that's also another useful feature of vectors. And then another function I'm going to show you guys is the popback function, where I'm just removing the last element. And on the bottom, I just put an image of some other things that you could use. So instead of like declaring a size with parentheses, you could just like use brackets and then inside put the elements you want to put into the vector once you initialize it. So now we have a vector of ints, type int, with the data with the 5 and 2 inside of it. But there's also
Yeah.
another thing we can do. You guys say something?
Yeah, just for clarity, so you put like when you're resizing a vector, do the vector name dot resize, not vector actually. So in this case where Brandon's writing like vector dot resize, it should be apples dot resize, but yeah, you get the idea. So also similar to basically what we showed yesterday in a string where you can kind of push back a character to the end of the string or pop back or get rid of the last character of the string. We also have the same behavior for vectors. So you can, it works the exact same way just for a vector instead of a string. So you can do push back numbers to a vector and you can also pop it back. And the thing about vectors that's really nice is that vectors are infinite in size. So whereas yesterday we had to kind of have an array and we had to kind of determine what size it is when we're creating it, vectors are dynamic, like Brendan said. So they don't have to have a set size and you can just continuously add and remove elements from them as you want. And it works the same exact way as arrays, basically. The only caveat of vectors is when they get really big, they are a little bit slower, but for the sake of competitive programming and kind of where you guys are at, mostly just use vectors. I would recommend. You don't really need arrays until you hit like a higher level. So for now, vectors are really easy to understand and use. So I recommend using them for now.
Yeah. And now I'm just gonna go over like the last bit of information I have here. So the last part, there's actually a separate thing you can do. So you can have the parentheses, and then the first input, you can put the number of elements like I've shown before, except now you can assign a default value to input all of them. In this case, it's assigning an array of size 5 to have the values 2. Okay, so now I'm going to go over maps, which are a different type of data structure. So they store key and value types, and you can define what type each of these are. Like in my example, I had the key as string, which is the left parameter, and then the right parameter as an int. And you cannot, two different values cannot be mapped to the same key. And then I'll just show what I mean by that right here. An example in the top left. So top right. So I declared my map, and then I want to put elements into it. So one way of doing this is with inserts, and then you can use these brackets to signify a pair of two different elements that you want to insert. So I'm going to assign the key triangle with an int of 3, which is the number of sides, and that works perfectly fine. Now let's do shape info.insert square and 4. That works as well. And then shape info.insert square 5. Okay, so the reason why this is not allowed is because you cannot have two different values assigned to the same key. That just won't work. So it won't let you do that. And then shape info.insert octagon 8. That works fine. And then I'm just going to show another way of doing this, which is shape info pentagon equals 5. You can actually, instead of doing this dot insert with the pair, you can just have this type of declaration, or this type of adding elements into the map. So there's multiple ways to do it, and on the bottom right, that's just a visualization of like, okay, how like the IDs are linked to like the names. That's how like the map structure kind of looks like.
Yeah, so map data structures can be really useful. So, for example, let's say that you were playing a game and a lot of like games have like a user ID or something like that. And you have a lot of information associated with your account, but as like a game developer who's writing the code for the game, you're not going to keep track of all the usernames and all the user information. You only want to be able to easily access each user individually. And using that, you can have like an ID. So here we can kind of represent that with the map data structure. So we can have an ID, and the ID is going to basically allow us to write something like here where Ben wrote shape info pentagon equals 5 on the last line of code. You can write, like for example, if it was a game, you can write game information brackets, the user ID number, and then you could get the information about the user and so on. So that could be something that's useful for something like that. So overall, maps are really useful for looking things up and basically keeping track of data easily and like basically managing it.
Yeah, and like another thing is just like when you go further into comparative programming, like if you want to like access and check if there's a certain key in your map, it's like constant time. So that's really effective for that. Like it's really fast for that operation. So yeah. And then sets are another data structure. It's the last one I'll go over today. So what's unique about a set is that all its elements are unique. So if you put in multiple of the same element, it's not going to put it in. It's just going to keep what it has like so far. And then in the set, all the elements are sorted in increasing order. So that's another thing you might find useful about sets. And the values are unindexed, meaning like I can't just do like, okay, set name, like bracket like 3 or something, and then try to get the third element. That does not work with sets. So now I'm gonna do set int nums, and then okay, I'm gonna insert a 5, and then I'm gonna insert a 4 right here. So nums.insert 4. And I'm gonna call insert 4 again, but it's just gonna stay the same because you're not allowed to insert duplicates. And now I'm gonna insert 2, so that works like as expected, except like instead of like a normal like vector, it would go to the back, where it just goes in the increasing order with the set. Now I'm gonna print out the size, which works in 3. But then with sets, there's an operation called dot empty, and it returns a boolean. If your array is empty, it'll return true, otherwise false. In this case, we have a set of size 3, so it's gonna return false. And then I'm just demonstrating that you can use for each loops with nums. I mean with sets. So I'm gonna run a for each loop to access individual elements of our set of nums, a set of elements, and then I'm printing out each one. So what this is going to do is it's going to ask the first element, print 2, and then 4, and then 5. So that's how the set works.
All right, so next I'll be going over functions, which are kind of one of the most important topics that you go over just generally in programming. So first, we're going to have functions being, we're going to go over their use cases. So first of all, functions are going to allow reusability of code. It's going to organize it and it's going to make it easy to read and find errors. So they're overall really useful. So think about tasks that normally in your life you hate doing, making dinner, cleaning your room, or doing homework. So normally, let's say you want to make dinner. Well, first I have to go downstairs or to the kitchen. Then I have to like kind of open the drawers and get my forks out, open the fridge, get the food out, and then kind of put it on my plate and then microwave it. And you can see basically like there's a lot of operations that happen just for one simple task. And in our daily lives, we're not subconsciously thinking about like, oh, I'm gonna go and pick up this fork and then put the food in my plate. You just automatically do it. So you can think about it the same way for functions. So we're basically just automating code and making it kind of repeatable and like into your daily schedule so that you don't have to think about it, but it's just operating. So functions in C++ are written in this syntax. So on the left, we can see the return type. So functions are going to perform an action, which is basically represented by the code executed. They're going to have a return type, which means what the function is going to return as a result of you running it. And of course, you have to put a name for your function. So that's what we're doing over here. And finally are any parameters that you want to consider. Anything that you want to consider like to change the behavior of your function based on what the input is. So we're going to have the return type, the function name, anything that you want the function to consider. And using all this, we can execute some code using it. So here are some fundamental function return types, and you'll notice that they're kind of similar to the data types that we discussed in the first day. So a function can return many different types of values. It can return an integer, double, float, bool, string, char, which are all we taught before. But there's also certain cases where you don't want the function to return anything. You just want the function to do something. So in that case, we would write void as the return type over here instead of like int, for example. So all these values, function return types, you just have to write it over here and it'll basically determine what type of value the function is returning. So to return or call a function is when you're going to actually want the function to do something. So I can create this function, but unless I use it, it doesn't do anything, right? So if I want to use it, what I would do is I would just call the function name and write a set of parentheses after that, and I'll perform all the code inside the curly braces. And this is just for like a general function with no parameters, but assuming that the function has some change of behavior based on how the parameters are, you have to include the parameters over here, and they're going to be able to be used as variables inside the curly braces over here. And just for clarity, each of these parameters has to be formatted in a specific way when you're defining the function over here. So let's say I wanted to create an integer parameter. So I would write the data type of the parameter, and then I would just write the name of the parameter. I can just say A. And then if I want to have a second parameter, I can just say something like integer B. And that's basically how we're going to create parameters inside a function. All right, so let's take a look at an example. So this is a pretty simple example that basically just asks us to write a function that returns the sum of two numbers. So here we can see our function. Functions go above the main function. So far we've gone over the structure of a C++ file. We start off with our header. We're including the modules that we need. And then we're going to use namespace std again, just to shorten up the code. These two lines are just like essential to put at the top. You could do IOStream again, but basically like this is just for simplicity. And then here is our main function where we're going to have all the code here be automatically executed. And between the header and the main function is where we're going to include any other functions that we use. I know in Java, after your main function, like you might have a main function over here. I heard some of you use Java on the first day. So you might have like a main function here, and then all your other functions are below the main function. In C++, it's just the opposite. You're just going to place all your functions that you want to create and use above the main function instead. So here, what we're doing is we're creating an add function, and it's just going to add two numbers. So if we're thinking about adding two numbers and returning the value, well, the return type is obviously going to be an integer. So that's why I put int over here. And here are the parameters that we're considering. So since we want to add two numbers, we need two parameters. They're both integers. And I just put a and b as their names. And all I have to write here is return a plus b. And that'll basically get the value of a plus b. And yeah, Samir, I see you raising your hand. Do you have a question?
Wait, so do we have to give a value to A and B integer?
Yeah, good question. So A and B, when you're defining the function, you don't put a value yet because we don't know what we want to call the function on. So if I didn't have this line of code, for example, we need this function to be generalizable to any values of A and B. If I want to add 5 and 7, or I want to add 9 and 12, I want to add 21 and 30. I don't know those values that I want to call yet. So I don't define them inside here. I just call them as inputs when I'm running the function or like trying to call it. So the function here is the only thing you do here when you're writing your function is define what it does. But when you actually want to use it, you use it in your main function over here. And you just have to input the parameters where you want to add the two numbers. So what's happening behind the scenes is we have this function defined that's going to return the sum of a and b. We're not using it yet, though, so nothing's going to happen by just writing these lines of code. But we want to run the code of the function. We're going to print out what it's returning. And we're basically just going to call the function using its name, add. And we're going to input two parameters. Because we have two parameters when we're defining the function a and b, we just have to put two parameters here. So 2 is going to get assigned to a, and 3 is going to get assigned to b. And that way we're going to be able to count 5 out here. So Samir, does that answer your question? Let me know if you still need an explanation.
Yeah, okay, so that means that when we do count, we call out integer add, we just give value, we're just adding a value to a and b in the parentheses.
Yeah, exactly, you got
Yeah,
it.
that just answers my question.
Yeah, okay. So that's kind of a first example.
Did you say count returns? Because like count doesn't return, count just prints, right?
Yeah, returning doesn't.
The return
Yeah, just for clarity. Yeah, so return a plus b means a plus b is going to be the value of add, but it doesn't print it out automatically.
Basically. Like
yeah, basically this entire thing will be 5, but it's not going to print anything out unless we write count. So that's why I wrote that here. So just for clarity, count is different from return. Return is just going to give a value. It's going to assign a value, but count is going to actually print it out. Count is the only thing that will actually print things out inside your console.
Isn't the return just giving it a function or some function to what it has to do?
Yeah, basically we're just writing return and it's just going to give the value. It's just going to do all the logic over here in the function and it's going to give the value, but it's not going to print it out.
Without cout.
Yeah, without cout, correct. Yeah.
Okay, we'll move on to the next one if that's.
So that was the first example. Let's take a look at our second one. So here we're asked to write a function that has two parameters, x, which is an integer, and r, which is a vector. So using what we learned so far about vectors, we want to return true if the vector contains x and false otherwise. So I guess you can think about this as like a useful example. You have to, these are kind of just mini problems, subsections of big competitive programming problems and like basically patterns you'll see. So let's say I wanted to go to the store, but I didn't know if the store had something that I wanted to buy. So I could look through the entire store list and kind of check if the item I want is there. Otherwise, I wouldn't want to go to the store, right? So here, this is like kind of like a useful example of that context. So we just want to check if an item is inside an array or not. So to do that, we can have a function for it. So if I didn't have this function, I would have to, every time I want to check if an item is in a store, I would have to rewrite the lines of code 5 through 16 over and over and over again. So that gets really complicated and messy. So instead of having to repeat that over and over again, I'm allowing the reusability of code by putting all of the code inside a function. So let's take a look at the main function first. So I'm just defining a variable to be a equal to 8 and vector int array equals 1, 2, 3, 4, 5. So I'm just having some values over there and as an example for you guys to see. And I'm printing the result using count again and calling the function with the vector and a. So from this, we see that like we're trying to return true, the vector contains X and false otherwise. So we see that the number 8, which is A, isn't inside the vector. So we obviously want to return false at the end. So let's see how we're going to do that. So when we're calling this function is an array, we're passing in R as the first parameter. So this R, this array is going to get assigned to this one over here. And X is going to be A because we're passing in A over here as the second parameter when we're calling the function on line 25. So A is going to go into X. It's going to represent X when we're calling the function. So that's basically what's happening behind the scenes, but let's go over the code of the actual function now. So we're going to use a trick that we mentioned yesterday about kind of like the assumption tactic. So we're going to start off defining a Boolean variable condition equals false. So we're going to assume that the vector does not contain the value X. So we're going to mention it to be false. And basically what we're going to do next is we're going to loop through the array. So we're going to say for integer I equals 0, this is the first number we want to check of the first index of the vector we want to check. So we're going to start over here basically. We're going to go all the way up to, but not including array.size, because remember, we're using indexing. So array.size over here is 5, but we don't have an index 5. We only have an index 4. So I don't want to put less than or equal to, I just want to put less than. So this is index 4, and that's why we're putting array.size. It's going to be less than that. So we don't want it to go up to 5. We want it to go up to 4 inclusive. And then we're going to just increment I. Basically, what we're doing here is we're going through all the possible indexes of the array so that we can access each value individually. So then we're going to use an if statement. We're going to say if array at index I is equal to X, then we say condition equals true. So right now we're checking if the value that we are currently at inside the array is X, then that means that this entire problem was true because we've been able to find a value inside the vector that is equal to X. And so this entire thing is true. The condition will be true. So basically what we're doing here is we're looping through the entire array using the index. So I is equal to 0 and it goes up to 4. So I'll check array, let me clear my screen quick. I'll check array 0, 1, 2, 3, and 4. Sorry for my bad handwriting. So again, A is equal to 8. So we're checking if array 0 is equal to 8. So that's obviously not the case. Then we're checking if array 1 is equal to 8. Same thing, not the case. Array 2, array 3, and array 4. So we found that overall, when we're looping through the statement, this code over here inside the if statement will never execute because array I is never equal to the value of X because it doesn't exist in there. So after we've been able to determine that, this code will never execute. That's why we made the assumption that it's false, because we wanted to make sure that we just wanted to set the condition that it was never true. And based on this value, since we understand that the only way that condition can be true is if we actually found a value inside the array to be X, but that never happened, then we know that the value doesn't exist. So we've been able to confirm our assumption, and all we have to do is check over here. If the condition is true, then we're going to return true, and otherwise we're going to return false. So notice quick that I don't need an else statement after the if statement. The reason for this in functions is that it's just a little bit shorter. Of course, you can have an else statement if you guys want to for clarity, but basically what's happening is after you write return in a function, that's the end of the code that the function will consider. So it won't run anything else. So let's say like I started defining variables here. I said like integer b equals 0. Well, the function will never know that if it's returning this right here, because the code would just cut off over here and like you wouldn't need anything else. So here I'm only checking if the condition equals true, then I can return true, and then this whole function will terminate, and then it won't run anything else. Yeah, Samir, I see your problem hand again, so go ahead.
So after let's say if return happens like in the for loop, this part stops.
Yeah. If I have a return statement inside the for loop somewhere here, and it actually runs the return, then this code will never execute.
So none of this part will execute.
Yeah, this part will execute. This is just in the main function.
Okay.
Just in context of the function. That's about it.
Yeah, okay.
Yeah. So we're just going to return true. And if this doesn't return true, that means that we just return false, and that's about it.
Yeah. And like there's another way to do this as well. Like the instance you see that like array I equals X, you could like just simply just return
Yeah,
true.
you can return true right there. Yeah.
And then it would just terminate and then not look through the rest. So like
Yeah.
that's another way to look at it. Like you wouldn't even need like these
Yeah.
variables if you want to do
Just
it
for
like that.
clarity, we didn't if statement, but yeah, like Brandon said, we can put a return statement right here and say, oh, we found it. So we don't have to look through anymore.
Yeah, that's another
Something
way.
like that. Yeah. All right, so let's take a look at our third problem, which is more USICO-ended. So we're starting with Bessie the cow is hosting a summer party next weekend. So her friends have sent her their names and the country they're coming from to Bessie, and she's recorded this information in her notebook with each entry being in the following format. So we're gonna have like a name is the key, a colon, and then the country. So in this problem, we're asked to write a function that takes two parameters, the friend's name and Bessie's notebook. And with this information, we want to return the country that they're coming to the party from. So this can be useful in like basically like guest checking. You want to see if the person you like, let's say I was hosting my birthday party and I kept track of everybody who was coming. Well, I want to confirm like if they were actually a person who's coming to who I invited, or are they just like a random person from the street, right? So I can have that by storing the data inside a map. And that's like the key realization from this problem. So essentially what we're doing is we have our function here. So notice that the problem asks us to return the country that they're coming to the party from. So using this, we have to kind of interpret the wording and say, okay, since it's asking to return a country, well, we have to return a string, right? Because a country is basically represented by a string. So that's why I'm writing string over here, because that's the intended data type that we plan to return. So that's basically where our function is going to be. And here is our main function where we're going to actually just test out the code. So I'm creating a map, and it's going to take in two inputs, which are the name and the country. So both of these values are strings. So that's why I'm writing string over here. Let's say I want to put like, instead of country over here, I could put year born. Year born. Sorry for my bad handwriting again. But yeah, basically, if I wanted to have the year born, I wouldn't have a string. I would have something like an integer, right? Because that's more representative of what the data type is. So here, since I'm using name and country, that's why I'm using string and string as the values in the map. And all I have to do is call the basically just write down the name of the map. So I called it notebook because that's basically what it is in this context. She's writing everything inside her notebook, recording the information in her notebook. So that's why I called it for clarity. And then, so let's say that Elsie signed up for her birthday party or got invited to it. So what I would do is I would write notebook. I would put the square brackets here. I would put the name that the new participant is coming from. So in this case, I put Elsie, and I say equals USA. So that's basically going to assign the map to have an entry in a notebook entry in which the name is corresponding to the country. And just like for clarity, one more thing, again, for those of you who know Java or Python, just like for you guys to understand, Java is basically has like a very similar functionality with hash maps. So they work the same way. It's just like a little bit different in terms of the code. And Python, there's dictionaries which also work the same way. So here we've been able to assign the value of LC to USA, and we're basically going to print out what the function is returning here using count. So again, we're counting the return value of the function. So what this function does, it's going to take in two parameters, like this problem mentions, the friend's name, which is a string, and Bessie's notebook. So here we can see that the notebook is a map with string keys and string values. So here, of course, we have a string key and a string value as the type of map that we're using, and I'll just call it data for convenience. And all we have to do is return data at a name. So remember that basically all I have to do to look up values in a map is write the key value inside the square brackets. So I have to write, first of all, the map name over here. Then I have to write the square brackets and I want to access the key. So since we're given the name as a parameter, all I have to do is put the name over here inside the square brackets, and I'll return the appropriate value, which is the country over here. So that'll basically return the country they're coming to the party from. And as you can see, when we're calling this and we're printing it out, we get USA to be printed out in the console because that's the country that she's coming from. And it's the value associated with the name key inside the data for LC specifically. All right, so next I'll let Brandon go over recursion.
Yeah, so recursion is definitely going to utilize functions, and it might be tricky to wrap your head around, but I'll definitely show some examples and a visual to help you get a hang of it. So recursion is when a function calls itself. So basically, whenever you have an initial function and then your problem requires subproblems to be addressed, then, and this will allow you to solve the overall problem. This is a case where you might need to use recursion, and then the calls terminate when you hit a base case. So although this might be confusing, I'll definitely go over an example that would use this. So let's think of like a factorial. So like 5 factorial is the equivalent of 5 times 4 factorial. So the 4 factorial is a subproblem of the larger 5 factorial. And then if we do 5 times 4 times 3 factorial, you can see how we're dividing a bigger problem into smaller problems. So because we see this pattern, you might think we need to use recursion. But oftentimes that you can also implement recursive solutions in iterative ways, although this is not always the case. So let's go over a way we would address factorial using iteration. So I would probably just implement into the function the number we want to take the factorial of, and then do a while loop. And then as we keep on decrementing n, we're just going to multiply our answer by that. So then our answer would become 5 times equals 4 times equals 3 times equals 2 times equals 1. Then it'll terminate that loop. And then we have answer is now equal to 5 times 4 times 3 times 2 times 1. So we're returning 120 to the main function. And if we're looking at the main function call, this function essentially becomes 120. And then we're just going to print out 120 as expected. But what if I want to do this in a recursive way? How would that look like? So you know how like a while loop keeps on running as long as this is true? Well, instead of that, I want to create a base case where the recursion keeps on calling itself until we hit a condition we do not want. And here, if n equals 1, we'll stop calling because we're just going to keep on calling the subproblem until we hit 1. And in that case, we don't want to go on anymore. And then, however, if it's not equal to 1, we still want to keep on calling subproblems. So we would call the current number 5 times the subproblem. And how this essentially works is we're going to call the factorial recursive on 5. And then it's going to call itself. So then we're going to do 5 times, we're going to return this. And then we're going to return this, which is like, you can see how we're having the subproblems divided here. It keeps on going to a smaller problem. And then we're going to return this. And then we're basically going to return this. And then like in the end, it's going to look something like this. So then we're going to call factorial R1, and this will just return 1. And then everything will just go back. And then in the end, we'll be putting out 120. And I'll have a visualization that will make this clear in the end, but that's like the main idea. So how are these calls stored? Like I was writing like f factorial of like 5, 4, 3, but like, where is this actually stored in the memory? So there's a data structure called the stack that it's a last in first out definition. So what I mean by this is the later function calls that you put in there, those will be the first ones to come out once you hit the base case. So first it will call 6 times factorial 5. Like if we were doing factorial 6, for example, we would return 6 times factorial 5. And now this is now factorial 5's function call. And in the end, it will return 5 times factorial 4. And then 4 will run. And then 4 will return this. And then it will keep on going up. But then once we hit the base case, the stack that's on top will be the first one to be removed. And as I said, like this may be confusing, but I'll explain it later. And we'll start removing once we hit the terminating case or the base case, which is when factorial is equal to 1. And in that case, we don't want to keep on calling functions and we'll stop. So I'll show this on like IntelliJ because I want to have access to like a certain thing that will allow us to visualize the stacks. Okay, wait, so we have, oh, there's a comment in, okay, I'll read that later. Okay, so I have this right here, which is this is actually Java code, but I wanted to utilize this to get access to a certain software that will allow us to visualize how this actually goes. It's called the Java Visualizer. So with this, you'll be able to see how these calls actually work. So this is very useful. So currently we're on, I'm gonna call, I'm on this line and this is the debugger. So if I wanna go to the next line to test what it does, I'll go here. And then I want to test what happens if I call this function. So I'll step in and then I'll go here. So now we're currently on the function call. So I just called 7 and that's going to be inputted into the stack right here. And since this is not true, it's just going to go here and then it's going to call itself again. So I'm going to step into, and now we just called 6. So that's the next item on the stack. And then I'll go in again. And now 5 appears in the stack. 4 now appears in the stack. 3 is on the stack. 2 is on the stack. So we're on 2's function call, but it's still not less or equal to 1. So it's going to go again. And now we're hitting the base case. So since we hit the base case, this function on the bottom left is going to, this is going to return 1. So now let's run next. And then now it just returned 1. So now f of n minus 1 is now equal to 1. And since we're on 2's recursive call now, since that's the latest item on the stack, this is 2. So 2 times 1 equals 2. So now a function call of 2 equals 2. So let's call next again. And now that one just got popped in the stack. And now the latest element on the stack is 3. So we just learned that factorial of 2 is 2. So now we're going to put 2 into here. And then we're going to put 3 because now we're on n equals 3. And now we know that f of 3 equals 6. So we're going to keep that in mind. And then we're going to run next. And we're done with this function. Now 4 is the latest function in the stack. So since we know f of 3 equals 6, f of 4 minus 1, which is 3, equals 6. And then currently n is 4. So now we're going to put 4. So now we know that f of 4 equals 24 due to multiplying these together. Now we're going to run next in the debugger. And now we have 5. So then 24 is f of n minus 1. That's 24. And then n is 5. So now we know that f of 5 equals 120. And you can see how it's basically just like going back and all the previous function calls are now adding up. But yeah, so let me pop back again. And now we're at 6. So then f of 5, which is n minus 1, is 120. And then n, which is 6, that's 6. So now f is 6 is equal to 720. So we'll store that. And then now we're going to pop, and then this call will no longer exist. And then we'll go here. We know that f of 6 is 720 due to our previous operations. So 720 times 7 is 5040. And then this is the final call in the stack. So f of 7 is the thing we initially called. So we're now going to actually return 5040 to the function, to the main method. So now we have 5040 as f of n. And then we're just going to print it. This is the equivalent of cout. So now we print that and we're done. So now I'm going to go back here and then 5040 is printed on the terminal.
Yeah, so recursion is all about like visualization. So like one way I guess you can understand it better is like, let's say that I'm at, so you know when like specific companies in like a mall or something are selling products and you have to like wait in line. There's like a long line that you have to wait for to get into the store as early as possible if you want to buy the product. Well, I guess you can kind of use this as an example. So let's say I have a bunch of people in line. So person 1, person 2, person 3, etc., all the way to person 100. So let's say there's a big timer over here, and person one knows how long they have to wait using the timer to kind of go inside the store and buy what they want. So person one knows the answer to this, but person two stands behind person one. They don't know, they don't see the timer, and they don't know how long they have to wait. And same goes for person 3, 4, 5, all the way to 100. Person 100 has absolutely zero clue how long they have to wait for to get into the store, right? So the idea of recursion is person 2 can ask person 1, hey, how long do I have to wait for the product? And since person 1 knows the answer, they can give the data back to 2. And then person 3 doesn't know how long they have to wait for the timer 2. So they can ask person 2, then person 2 can ask person 1, and person 1 knows the answer. So person 1 will tell person 2 will tell person 3, and that's how person 3 will get the answer. So the same thing applies for person 100. Person 100 will ask person 99, 98, 97, so on, until that entire thing comes to person 1. Once it comes to person 1 knows the answer. So they'll tell person 2, they'll tell person 3, 4, 5, and the information will transfer all the way back to 100. And that's how person 100 will be able to find out the information. So it's kind of like the same idea with what has happening behind the scenes in C++, or like Java, like Brandon said. So in the case that we were asking for like 6 factorial, which you know in math, so 6 factorial is basically 6 times 5 times 4 times 3 all the way to 1. Well, if I want to find 6 factorial, this is kind of like the last person in line. This is person 100 in line. This is person 99 in line, and so on. So basically, I'm saying, okay, person 1 is 1. Person 2 is going to be asking person 1. And then like basically, this is going to go on. And we know that 1 factorial is 1. So it's going to tell 2 that it's the value of 2 factorial is 2 times itself. So it's going to return 2. So this entire value will be assigned to 2. Then person 3 is going to know, well, 3 factorial is just 3 times 2 factorial. And we already determined 2 factorial is 2. So this information is going to get passed on to here again. So it'll be 6. And then this whole thing is going to happen again. So it'll be 24, 120, and finally 720. So that's the idea behind kind of recursion and visualization of recursion. So visualization is really important in recursion. It gets really confusing, but the idea about recursion that you guys should keep in mind is think about what type of information you're guaranteed to know as the base case, and kind of work around with that and be able to kind of get a formula for how the information is going to get transferred. So with that, we'll go over yesterday's homework, which was pretty challenging. So we started off with problem 1, which is to write a program that asks for the user to enter number X. Then it's going to kind of create an integer array of that size and ask the user to enter numbers to store in the array. And finally, we're just going to print out the maximum value of the array. So there's many ways to approach this. And if your code is similar to something like this, or like has similar ideas to it, that's perfectly okay. Even okay if you want to use a vector and get a little ahead. So here we're defining X and we're reading it in just as the problem says. So ask the user to enter X and read it in. So integer X, and we see an X. Then on line 8, you can see that we're creating the array as the problem says. So we say integer array of X, and basically it's just the size of the array. And here's where we define the data type. So then we're going to go through every index of the array, read in a number, and kind of just assign array at index I to be num. So basically what's happening is we have 0, I is equal to 0, 1, 2, etc. until it goes to X. And this is going to assign all the values in an array to a number that the user inputs one at a time. So that's what's happening here. So we're going to basically get an array filled with a bunch of numbers. And over here, you guys don't have to use this yet, so but I just put it for clarity. So you guys can put like -1 or something that's like whatever. You could assume that the values that the user input are positive, but so that's why I was mentioning to use like -1, for example. But basically, like I just want to get the maximum value of the array. So if I create like the minimum value of answer over here, which is -2 to the power of 31, or whatever like the integer bound is, then basically I can say that this is basically just think about this as I'm creating an integer variable that has a really, really, really negative small value. So that means that if I say anything bigger than it, then I'll be able to know if it's bigger than the current answer. And that's useful because we want to print out the max value of the array. So you can check every value inside this array and check if it's bigger than this answer. All we have to do is compare it, right? And once you compare it, we'll be able to see if it's bigger or not and basically get the maximum. So the idea here is we're going to start from the first element of the array, which is at index 0, and we're going to loop through the entire array using the size of function that we were mentioning yesterday. So this is just basically the length of the array. You don't have to memorize this anymore, especially since you know vectors, but basically this is just the size of the array. And we're going to loop through the entire array with I++ as well. And we're going to see if the answer can be like, if we can get a bigger number from the array. So basically we're using a max function. You can also use an if statement, but here we're using a max function from what we taught yesterday. So the new answer, which was initially integer minimum, is equal to what it was before and the maximum value between what it was before and the current value that we're at in the array. So let's say the array was like 1, 2, 3, 4, and 5, like over here. We'll loop this entire array and we'll check first of all at 1. Is 1 greater than a really negative number? Yes. So that's the maximum between a really negative number and 1, which is the first element, is going to be 1, obviously. So we're going to say answer equals 1. So answer equals 1 now. Then we're going to check 2 over here. The maximum value between 1 over here, which is what answer is, and array I is going to be 2, is 2, obviously. So the new maximum is 2. And this whole thing will kind of repeat itself until it gets to 5. And then the value of answer will be 5. And all we have to do then is count it out. So that's the idea behind this problem. We're just using the max function and looping through the array. So challenge problem 1 is a little more difficult. So essentially what this problem was asking for, if you want, you can click the link to it. And basically what's happening is it is going to take in as input the amount of coordinates on a coordinate plane, like an x, y coordinate plane. It's going to take in the amount of coordinates that we want to consider, which is n. And then we're going to basically try to get the maximum distance over here. So originally what we did was, well, we want to implement like the use of vectors. So we're saying integer n, we read in n, and we're separating it by x coordinates and y coordinates using vectors. So because that's like kind of the way that the input is being given to us. So I'm creating vectors over here, and notice how we don't have a size for them. So whereas if we were using an array, we'd have to define the size of the vector, but we don't have to do that with vectors over here. So I can just call vector, the integer data type here, which is what we're going to store inside the vector, and then the name of the vector, which is x coords and y coords. So we're going to loop through the amount of coordinates that the input wants us to have. Then we're just going to get the input that it wants and read it in and push it back to x coordinates. So then we're going to do something similar for integer j. So I just use a different index. You can use I because like you can reuse that variable. But basically what we're doing is we're reading the x coordinates and we're reading in the y coordinates. And we're trying to get the maximum distance from kind of like the origin, I guess. So if you guys recall from like math class or something, I'm pretty sure most of you have gone through like at least some basic geometry or algebra. The Pythagorean theorem or distance formula can be applied here. So basically we're trying to get the maximum distance from the origin. So if I'm over here and let's say a point is over here, think about it as like this is the distance that we want to find. And if I draw a line straight down here, you can see that there's a right triangle. So this is x and this is y. And you know that x squared plus y squared equals d squared. So if we want to find d, then it's going to be square root both sides, right? So d, the distance that we're trying to find, will be square root of x squared plus y squared. So that's kind of like how we're thinking about approaching finding the distance. That's like the conceptual idea of finding the distance over here. So here, I'm going to store all the distances inside the vector. So what's basically happening in this problem is we're given a bunch of x coordinates and y coordinates that are around the coordinate plane. and we're trying to find the maximum distance to any of these coordinates. So the idea is that we're going to loop through each coordinate and basically get the value of the x squared plus y squared. And then we're going to take the square root of that. And then we're going to be able to get the distance from that value. And then we're going to put it inside this vector of distances. Let me know if you guys want a re-explanation of that. But essentially what's happening is we've gotten input to all the x and y coordinates. So like over here, over here, over here, and over here, over here. And we want to find the maximum distance from the origin. So which one of these lines is the longest, basically, is what this question is asking. So to do that, we're going to loop through the x coordinates and y coordinates. I won't go too in depth about that. But basically, if we want to think about it again, this distance is d, this is x, and this is y. And oh, sorry. So this problem is actually not asking for distance to the origin. It's just distance to any other point. So just clarify that. So for example, this is point 1, 2, 3, 4, and 5. It's asking for the maximum distance between any two coordinates that are given. So in this case, like I guess you can just kind of eyeball it and see that 1 and 4 are the furthest from each other. So the way we can kind of see this is the same concept. So if we're looking at 1 and 4 specifically, well, we just have to look at the coordinates like this and draw the right triangle again. So this is the distance that we want to find, d, and this is y and this is x. So basically it's the difference between the coordinates y values and the difference between the coordinates x values. Once we have that information, we can apply Pythagorean theorem and basically derive a formula to be able to get distance. And we're going to store all those distances inside this vector. So next, what we're going to do in this code over here is loop through all the different coordinates. We're going to say integer dx is the absolute value. Remember that we taught that yesterday in like the standard library function. So we want to get the difference in the x coordinates. And then we're going to create another variable for the difference in the y coordinates. So something like this. And using that, we can kind of calculate the distance squared. I just put distance because it's easier, but basically what's happening is I'm able to get the difference in x, the difference in y, and using that, I can apply Pythagorean theorem to get the long distance over here, which is what we're trying to store inside this vector. So because C++ has some like rounding errors and like generally programming languages aren't reliable for decimals, they're annoying to work with. So it's better, like always when you're like doing programming, it's always easier for you to kind of just work with integers. So whereas I can do something like d equals square root of like 37, for example, I wouldn't want to write out the decimal value for this because it's not going to be like precise. But if I write square root of 37, it's really precise. I know exactly what the value is. So instead of storing d over here as like an imprecise decimal, I can say d squared equals 37, right? I just have to square both sides. And I'm going to be able to get this value over here. And all I have to do is compare all the different d squared values. And through that, I'll be able to get the maximum distance. So essentially what I'm doing, again, to reiterate, I'm looping through all the x coordinates and y coordinates that are basically given inside the arrays that I stored between different points. So I'm looking at this right triangle over here. I'm looking at this right triangle over here, et cetera, et cetera. I'm getting the maximum distance that is happening between the two coordinates. And I'm using that as d squared. I'm calculating the difference in x. I'm calculating the difference in y. And I'm going to use that information to calculate d squared and store that over here. So that's basically what this is. I'm getting d squared and x squared and y squared, and I'm setting it equal to distance, and I'm pushing it back to this vector. So at this point, what I've been able to establish is inside this vector, I've been able to get the distances between every single coordinate that is given in the input. So I've been able to establish this distance, this distance, this distance, this distance, et cetera, et cetera. There's a lot of different distances in this problem, but basically the idea is I've been able to calculate the distance between every 2 points inside the problem that are given as input. And I've stored the distances over here. So all I have to do now is say, okay, so I'm going to loop through all the different distances. I'm going to say, similar to what we did in the last problem to get the maximum value, we're going to say the maximum distance is equal to the maximum value between the current distance and what we stored inside this vector over here. And then all we have to do is print it out. So that's kind of the idea behind this problem. And the next challenge problem, this is a use code problem that we mentioned. So of course, this is pretty difficult. So don't worry about it if you guys couldn't find a solution. This is basically just for you guys to think about it. Even if you guys can't write the code, even if you think about, just read the problem and think about how you can solve it, or like kind of brainstorm what data structures or what code you could write, that's perfectly okay. So here in this problem, we're going to basically, I'll ignore this file IO for now, but I'll mention it later on. So we're going to read in the input n and k, which is, okay, so I should mention what this problem is actually first. So essentially what this problem is it's giving, Brandon, could you open the link to the problem so I could kind of better explain it?
Okay. I want to explain this whole problem because like we're almost hitting the hour. So
yeah, so I'll explain it pretty quickly, but yeah. So essentially what's happening is it's giving how many letters are inside Bessie's essay, and it's giving the maximum characters that you can have on a single line. So which is K over here. So basically, like I guess you think about it as like a piece of paper. So I have an entire essay written out of n words, and each line is on this piece of paper can only contain a certain amount of words, like a certain amount, because there's not enough space. So if there's too many characters, I have to move on to a new line, right? So that's basically what this problem is saying. So this is the page size, and this is the amount of words in the essay, and it's going to give me the essay over here. So then all I have to print out is the, basically, if I have a piece of paper again, I can only have a certain amount of words over here, and I want to print out the essay, but on this piece of paper instead of in this one line format. Whereas the essay here is in one line, I want the essay to be distributed among multiple lines over here of size K at most. So this is K characters and this is 0 characters. So that's the idea. So Brandon, you can go back to the code now. Okay, so the idea here is we're going to read in our inputs here, and we're going to set a temporary variable of current line length is 0. So of course, we don't want this value to exceed K, because like I said, if we have a page number here, each line can only have K characters. So I'm keeping track of a variable outside the for loop for the current line length. So then I'm going to loop through all the words that are read, loop through all the words that the problem wants me to input. I'm going to store them as a string because the words are represented by a string data type. I'm going to read them in using cin. And I'm going to just write out for reference that the length of the string is s.length. This is just to get the length of the string that we mentioned before. And we're going to say if the current line length plus string length is less than or equal to K, then we can add it onto the same line. So the idea behind this is we have our current line length and we want to add a new string here. Well, we have to see if it fits, right? So we're going to add those two together and see if it fits within this K value. And if it does, then I'm basically just going to print out the string and I'm going to add the string length to it. So if I have the, for example, for my essay, and I want to add the word cat, well, I can't add this cat until I can comfortably see that I'll fit inside this line, right? So I want to make sure that this adding the cat part of the essay will not make it overcrowd over here on this page. And if it doesn't overcrowd, then we've been able to successfully add cat to the same line of the page. So the new line length is going to be the and cat. So instead of the line length being 3 originally, now the line length is going to be 6. So we need that for the future, right? Because we want to see if future words can be added as well. So this is just to test out if the current one we're considering can be added to the same line. So if it can be added to the same line, which is basically what this is saying, then we just wanted to separate it by a space. So normally, if I write name, is Brian, for example, like you could see that I have a space between each word over here, but I don't have a space in front of the first word. So I'm saying if the current line length is greater than 0, that means I already have a word here, then add a space in front before I print the word. So I'll basically create this space and I'll print this word. But if it was the first word, it wouldn't create the space. So it would just print the name out. So that's basically what that is doing. So if I'm able to add the string to the current line, then I'll do so. Otherwise, I have to start at a new line, right? If this entire row of words is filled up, then I need to start at a new section of the page, a new line of the page. So else I'm going to say current line length is equal to 0. I'm going to reset it because now that I'm at a new line, there's 0 characters here. And then I'm going to create a new line basically. So from this line over here that we don't want to add on more words to, then you're basically just going to create a new line where you can start fresh. So that's what count endl means. And then I'm going to print the string value. And then I'm just going to say current line length plus equals string length. So this new line currently has the length of the current string that we're adding. So that's basically what's happening in this problem. One more thing, sorry. So I mentioned earlier that we're opening the file up top, so you don't have to worry about this too much, but basically what's happening is we're reading the input from the file word.in and printing it to word.out. So that's basically just file IO that we showed from the first lesson for reference.
Yeah, and that's only useful for like older problems. In the current use
Yeah.
code format, you won't need to know that. So
yeah, and lastly, we're just going to go over today's homework quickly. So this is kind of like the end. So firstly, we've gone a little bit simpler with this homework. Yesterday's homework was really challenging for you guys, but good job to those who did it. So today's homework, the first problem is going to be to write a program that takes as an input an integer n and is going to return the first n Fibonacci numbers. So the Fibonacci numbers are basically where each Fibonacci number is the sum of the previous numbers. So the first two numbers of the Fibonacci sequence are 1 and 1. And then since from now on, basically the next Fibonacci number is the sum of the previous two. So the next number will be 2, the next number will be 3, the next number will be 5, 8, 13, and so on. Basically, you could see that 13 is the sum of 5 and 8. 8 is the sum of 5 and 3, etc., etc. So write a program that takes an integer n and prints the first n Fibonacci numbers. And then we're going to ask to write a program that takes a string as input and returns the reversed version of that string. Hint, hint, both these problems are using recursion, so have a good think about that. And lastly, we have a simple problem that we linked over here that's a lot easier than like the use code ones that we mentioned so far. So you guys can kind of see that and kind of get used to what we taught today and like a little review on the past days. So yeah. And that's about it for our meeting today. Thank you for coming. So today is Thursday, so let me see tomorrow. Today we covered basically fundamental data structures, functions, and recursion, some of the most fundamental topics of programming. So tomorrow is going to be kind of a wrap up of C++ syntax. So syntax